Okay, folks, so this is the lecture number 2 about a histogram. So I announced that before that we are going to have this lecture with the help of TI, or I will do something with the TI. So I have my TI calculator TI-84 plus silver edition here, and you can also probably get something like that. And this is the thing you want to probably use in the statistic course from now on, every now and then. Okay, so I was saying last time that we have this set of numbers that represents, this example 1, represents the single purchases by a customer in a certain gift shop, and they are rounded to the nearest dollar. So the first customer purchased the $10 gift, second one $8, third one $15, and so on. The first thing you want to do probably is to sort it, and to make a histogram you will actually need to sort it. So histogram is a vertical bar graph that will require you to sort the data. Okay, so for that you could use the thing that I was doing in the class last time, which means you go until you find the smallest one through all of the data, write it down, cross it over, get the next smallest one, write it down, cross it over, and so on. That's going to take a long time because there's 30 numbers here to do that. So it's slightly easier to do that with the calculator, because the calculator, by the way, is not going to make any mistakes, so this is advantage to have, right? So I'm going to use the calculator to sort this data. You can see the second set of numbers here says data sorted, was sorted from the smallest one 3 to the biggest one 26, the largest number, right? So I'm going to use the calculator to actually do this sorting. So the calculator for sorting, you can use something called start button. You can see the start button is the second button from the top in the middle. And if you press that button, it will give you an option to do a couple of different things, to edit, to calculate, and to do some testing. And we are going to use the edit option. So I'm going to press the enter that enters the edit option. Why do I need that? I need that so I can actually put some data in. So I have lots of data here in the list 1. I have a bunch of things. In list 2 I have a bunch of things. List 3 and list 4 and list 5 and even list 6 I have lots of stuff. So I'm just simply gonna clear the first list because that's what I want my data to be. That's press button clear, press enter one more time, and the list is clean. You can also do the, I'm gonna do the second list just in case you know, have any anything that can confuse you. So clear the second list. Again, press the button clear, press enter, and the list is clear. Now let me go back to the first list. And in the first list I want to put this number. So the first number is 10. Then I have 8, 15, 12. So you type the number and then you press enter after you type the number. So that's how it gets into the list, and the next one shows up. So I have 5, 18, and 12. That's the next 3. I'm pressing the buttons and then I'm pressing enter to get the number in. So now I have 10, 10, 11. And last two numbers in the first row are 7 and 26. And then next row is 11, 3, 5. And then we have a 12, 22, 15. And the next three numbers are 18, 23, and 6. And the last three numbers in the first row are 11, 18, and 20. You can check that in your list right now I have 24 numbers. So the next one in the list, you can see, says list 1, the next item is 25th. So the 25th number is 9, and I have actually in the third row 9, 16, and 10. 9, press enter, 16, press enter, 10, press enter. And the last three numbers in the last row are 18, 15, and 9. Okay, so I have all of those numbers in, and the next thing I want to do is to sort them. So I am going to again press the button statistic, and in this button under the option edit you can see the edit, sort A, sort D, clear list, and setup editor. I want to sort it, so it's one of the following two, either sort A or sort D. What does that mean? Sort A ascending order, sort D descending order. Ascending from the smallest to the biggest, descending from the biggest to the smallest. So I want to do it from the smallest to the biggest. I'm going to select the option 2. Just move arrow to option 2. Press enter. You'll also it's not going to sort immediately because I have a bunch of lists over there, so I need to know what list I want to sort. Maybe I want a more, maybe I want a one, maybe just two, maybe, you know, whatever. Okay, you can sort all of them. So I am going to sort the list 1, list L1. So I need to put up L1. L1 is the blue option on the. If you look at the calculator, you have a digits down there, 1, 2, 3, and so on. And above 1 as a blue option is L1. The blue option is this button on the very top left, second. It says then there is also some green option, but we are not doing that. So second 1, that means L1. Now if I want to sort another list, I should put a comma and then, you know, I write another list and comma and another list and comma and another list if I want to sort multiple lists. But I don't need to do that, I just need to sort one list, which is the L1, the first list. I need to close parentheses here, so I'm closing parentheses. There is a button below tangent, the black button in the middle row. I press the close the parentheses. Okay, that's the thing needed. Now I need to press the enter to sort the list. And it's going to tell me done. And now if you press button statistics back again and you go to the edit, you will see that list is sorted. You can see now in the first list I have 3, 5, 5, 6, 7, 8 and so on. That's exactly what you see here in the row with the sorted data here. Okay, I'm assuming you have this lecture open, because I'm now going to switch on my whiteboard, but I'm not going to write those numbers again. So I'm assuming you can see them. This lecture is, by the way, attached to the lecture menu option in Blackboard. So you can see that lecture there. You can just click on that and it will open just like file, just like I open. I actually opened that from the Blackboard, so the lecture is there. So I'm switching because I'm going to start using my whiteboard. Okay. Again, so I'm assuming you see these numbers. All right. So if you want to make a histogram is a vertical bar graph. You will need to decide where is your histogram going to be. How is this vertical bar graph going to be drawn? All right. So the data that I have is from the number that is 3, that's the smallest purchase in that gift shop, all the way to the number that is 26, that is the largest number of the purchase value in that gift shop. So I have it from 3 till 26. Okay, this is called a range. You can say from 3 to 26. You can also say it's 23 because that's what the range is. Right? The difference between the biggest, so this is the minimum in the sample, and this is the maximum in the sample. And I know that because I sorted the data up. So the first thing in the sorted data is 3, and the last thing is 26. I know this is minimum and maximum, because I know that I sorted them in ascending order, in increasing order, right? Ascending. So now, since I have the data that is of the range 23 from 3 to 26, I want to decide my histogram is going to be positioned where. Well, the idea of the histogram is to cover the data. So the range of histogram must be the range of data. So which means the histogram is going to show up somewhere to cover the in the beginning in 3, and also have to cover 26 at the end of the bar graph. Okay. So histogram, the rule for the histogram. There's just few rules the way you are doing histogram. The first rule is the range of histogram has to cover the range of data. So you have a range of sample which is from 3 to 26. The range of histogram must cover the range of sample. So the bottom, the horizontal axis of the histogram has to cover 3 and has to cover 26 and everything in between. Okay, the next thing you need to decide, the second thing you need to decide is how many bars you're going to have. The vertical bar graph is going to have vertical bars. So how many bars you're going to have. The second rule about a histogram, it has to have at least 5. We call it classes or bins, bars. Okay. Now the bars is the whole thing. The vertical bar graph. The bins or the class is just the horizontal part of that, like the length of the bar, not the height. Okay. So it has to have at least 5. If you have a small amount of data, you're probably going to use 5 or 6 or something like that. If you have a large amount of data, you can have more bars. Okay. Now I have the data that has a 30 numbers in it. My sample is of size 30. This is called sample size. There are 30 numbers in it. Okay, some of them are repeating, but there are 30 of them. Okay, so it's what we call a big sample. Meaning what? We will use the boundary when we say big, and above that is always big, but below that is always small. It's going to be 30. So if you have 30 things, that's big. If you have more, that's of course big. If you have less than 30, like 29, that's small. Now this is very arbitrary. It sounds very arbitrary, but we have to do that. We have to decide when we're going to call sample big and when we're going to call sample small. So the sample is big when it has at least 30 things in it. Of course, when you're analyzing data, you probably want more than 30. But the sample is big when it's at least 30. So my sample is just barely big because it has really 30 things in it. Okay? So basically, I could use 5 classes, I could use 6 classes, but really anything more just doesn't make any sense. So I'm going to use 6 classes. So in here, I'm going to use 6 classes. This is your decision. You make that decision yourself. Whether you want to use 6 classes or 5 classes or anything more than that. But it has to have at least 5 to be called a histogram. Right? So I'm using 6 classes. Now you need to decide how is this 6 classes going to cover the data between 3 and 26. All right? Well, the range of classes have to cover all of the data. So the beginning has to start somewhere at 3 or before 3. And the end has to end with 26 or above 26, but it cannot end before that. All right? So the next rule about a histogram is that every class must have the same range. And to avoid the confusion, I'm going to call it width, because which means that every bar has to have the same width, and that's going to be the range of a class. So, what is that going to be? Well, you have a 23 here divided by 6. That turns out to be something like 3.83. As a matter of fact, it's 3.83, 3333, and keeps on repeating exactly like this. So you could use 3.85, which is going to be good enough, or 3.84. If you're a computer, you can calculate those distances really nicely. But for a human, it's kind of difficult to do that. So I'm going to use 4, because that's going to be much easier to work with. So the range of a class every class is going to be 4 for me. So again, I have to go above. You can say, why not 3? You can, because then you're not going to be able to cover. You're using something smaller than what the range of the data is, so you can't possibly cover with that. You're going to have to go a little more than 3.83, right? You can use 3.84, that would be bigger. But again, it's much easier to work with 4. Okay, now, the range of all classes. The range of all classes is 24, because 6 classes, each one has the same width of 4, and that makes it 24 total. Okay, 24 total. So now I'm thinking I need to cover 23, which is the range of data, the range of sample, 23 with 24. Okay, which means that I have 1 extra. I have my cover, or the classes, is 1 longer than the, or wider if you like, 1 wider than the range of data, which is 23. So to be able to do that, I think I'm going to do that by being unbiased, and the unbiased mean I'm gonna cover the toes and the head equally. So which means I'm gonna start not at 3 but at 2.5, and I'm gonna end up with 26.5. So that's the half before 3 and half above 26. That adds up to 1. So this is this extra 1 I have. Okay. Now you could say, let's go from 3 to 27, because that's 24. Or you can say, let's go from 2 to 26, and that's also 24. But the problem is that that's bias. I mean, you're covering the toes, but you're not covering completely the head. Or you're covering the head, but you're not covering completely the toes. So I am basically covering both. So I'm going half before here and half for there. So the range of all classes is 24, and it's going to be between 2.5 all the way up to 26.5. Check it out, this is 24. Right? The range is 24, this is what it's supposed to be. Okay. Now I have to find out where are the boundaries of the classes. Right? There is another rule here about a histogram that I didn't mention, and that rule is that there cannot be gaps between the classes. So if the first class ends somewhere, the second class has to start exactly there where the first one ends. Now I already know that what's going to happen. I'm going to have the 2.5, the beginning, and it's going to go for the width of a class. I'm going to have 2.5, 6.5. That's my first class. Then I'm going to have a second class, another 4 up. I'm at 10.5. Then another 4 up, and I am at 14.5. Another 4 up, I am at 18.5. 4 more, and 4 more, and I am at 22.5, 26.5. Okay? These are my classes. From 2.5 to 6.5, from 6.5 to 10.5, from 10.5 to 14.5, from 14.5 to 18.5, from 18.5 to 22.5, from 22.5 to 26.5. Okay? Now I know where my classes are. This is the bottom of my bar graph. I don't need this anymore. I'm going to erase this. People that are well organized are going to make a histogram, of course, nice. There's going to be vertical bar graphs, there's going to be some picture here. But also, they want to write the table. The table that will give you a little more information. So, in the table that I am going to write now, you would write a couple of things. Or maybe a little more than a couple of things, but few things. Okay? The first thing you're going to write is itemized class. Class or a bin. If you have many classes, maybe you want to call them. I have 6 of them. So let me see. 1, 2, 3. My table is not nice. You can see the lecture is much nicer because I use a word processor there. 3, 1, 2, 3, 4, 5. I need one more. Okay? So you can call the class number 1, number 2, number 3, number 4, number 5. If I use that, actually, I don't need that at all. But you might have some other names for the class. I don't know. What might be meaningful to you, like minimal purchases or something. I don't know. Depends. The second thing you want to have is the class limits. That could also be, you know, the third thing. But we're going to put that as a second thing. Limits. Limits of class. Okay? The limits of class are what's it going to be in this class. Apparently it's going to be 3, 4, 5, and 6. From 3 till 6. Any monetary purchase that was there between 3 and 6, $3, $4, $5, $6 is going to be in the class. So the limits are 3 to 6. In the next class is going to be between 7 and 10. What's in this class going to be the range is between 6.5 and 10.5. So it's going to be 7, 8, 9, and 10. 7 to 10. In the next class is going to be between 11 and 14. Any purchase that is between 11 and $14 is going to be in the third class. The fourth class, 15 to 18. The next class, the fifth class, between 19 and 22. To 22, and the last class is going to be anything between 23 and 26. These are called class limits. So whatever is going to be in the class. I didn't write 3, 4, 5, and 6, but the limits are from 3 till 6. That's the idea. But in the class you could have also 5 and 4. You also might want to write boundaries. Now the boundaries are already written down there, so I might just want to repeat them. 2.5, 6.5, 6.5, 10.5, 10.5, 14.5, 14.5, 18.5, 18.5, 22.5, and the last one is 22.5 to 26.5. Okay? Now you need to decide something here. In this particular example, it's not going to be a problem. There's not going to be anything on the boundary. I don't have 6.5 purchase there because it's the purchase is to the nearest dollar. I have a $6 purchase. I have also, I think, $7 purchase. Yeah. But I don't have a $6.5 purchase. But in either case, you need to decide. 6.5 is going to belong to the first class or to the second class. So which means your choice must be what's going to happen with this boundary here. If something happens to be exactly on the boundary, is that going to be in the second class or in the first class? So you have to make the decision. You can make left in, right out, or you can make a decision left out, right in. I'm going to make a decision left in, right out. So I'm putting this arrow here that tells you that I'm considering in this class to be anything between 22.5 up to 26.5, but not 26.5. It goes up to that, but not included. So which means that if there is any purchase of $6.5, it will go in the second class. Any purchase of $10.5 is going to go into third class, and on. Okay? What am I saying here is a very important rule, rule number 5, and I want to clutter that with a histogram, maybe I will not have enough space, is the classes do not overlap. Okay, so that's the last rule. The classes cannot overlap, so you have to decide what's on the boundary. Second class or the first class. The class before or the class after. This thing could be only in one of them. And you certainly cannot overlap them like, you know, one over the other one. Not even a boundary, much less that. Okay, so the range of histogram must to cover the range of the sample. You need to have at least 5 classes. You need to have every class with the same width as any other class. So if the one class is 4 wide, the other one must be 4 wide, not 5, not 3, but 4. Okay? No gaps between the classes, so it cannot be whole here. You left something out. You've seen one of my bar graphs that I was talking to you last time. You see the gaps there. There was a vertical, you know, blue bar, and there's a gap, and there's another blue bar, and so on. That is not a histogram. It's something else. Okay? Histogram don't have gaps between the classes. One bar is attached to another bar. Okay? And classes don't overlap. One item of data cannot be in 2 classes. It can be only in 1. Right? Now, when we have those boundaries done, we need to find out the frequency. You can do the tally if you're tallying by hand, because you need to find out, you know, what is in the class. How many things are in the class is called frequency. Now you look at the limits, 3 to 6, and you look at the data. Okay? So what I see here, that I have, you can see here what is the in sorted data, 3, 5, 5, 6, 4. 4 things are between 3 and 6. 3, 5, 5, 6. That means that the frequency of the first class is 4. I am counting how many things are in the first class. There are 4 of them. Okay? You can go back on the second class. And in the second class you can see the things ought to be between 7 and 10, we said, right? 7, 8, 9, 9, 10, 10, 10. Well, I'm counting that's another 10 here. 8 things are in the second class. 8 things. That's what we call a frequency of the second class. Right? So I'm going to leave that to you to count the rest, because it's really not that hard to do. But you will find that in the third class you have 6 things. There will be purchases between 11 and 14, so this is $11, $12, $13, and $14. I'll be 6 of those. And then the next class is going to have again 8, between 15 and 18. And the next class between 19 and 22, so it'll be 19, 20, 21, and 22. We'll have, let's see how many. Is this strange page opening? Anyway, so I have that, I said between 19 and 22. So take a look here. I have the, I don't have 19, but I have 20 and I have 22. So there's not more than 2 of them. Two things. And in the last class, I'm talking about the things that are 23, 24, 25, and 26. That's what the limit says should be. And I'm finding out there I have a total of 2 things there. It's actually only 2 purchases. One of them is 23 and one of them is 26, and that's it. Okay? Now we have something called, it's important to us, but something called relative frequency, and something called cumulative frequency. You can write them in either order, but I'm going to write the cumulative frequency first, and then I'm going to write relative frequency. I need 2 more things. Right? There is another thing also I'm going to tell you a little more about it in the right. Cumulative frequency. Cumulative with 2m, you can write it down. C-U-M-M-A-U, excuse me. C-U-M-M-U-L-A-T-I-V-E. I'm not very good in spelling, but that's what it is. It's cumulative with 2m. Cumulative frequency. I'm going to write frequency with Q, FQ. So I have to write all the thing. Cumulative frequency. Cumulative frequency. What's that? What is up to the first class, including first class? 4. What is up to the second class, including second class? Well, that's 4 and 8, so it must be 12. What is up to the third class? So that would be this and this and this, including third class. So basically you have 12 plus 6 is 18. What is up to the fourth class, including fourth class? That would be 18 plus 8. So 4 plus 8 plus 6 are all the other. That's 18 plus 8 is 26 things. Then what is up to the fifth class, including all of the previous classes? So that would be all the previous classes is 26. I added here, and then plus 2, that would be 28. And what is up to the last class? Of course, all of that in your sample must be up to that. It would be 30 things. Again, so if you add all of that, it's 30, or you just simply add 28 because it's the sum of all of those guys. So basically, this guy is this guy is the sum of this 2, this guy is the sum of this 3, this guy is the sum of this 4, this guy is the sum of this 5, and this one is sum of them all. This is a nice check also, because you can see 30 here. It must be 30. And if you don't have 30, that means you missed something, and you didn't count something in one of your classes. But since I have exactly 30, and that's what I have in the sample, I'm okay here. And then you have something called relative frequency. Relative frequency. Okay, what's a relative frequency? Relative frequency is the fraction of the class as opposed to the sample, or should we say the ratio of the class to a sample. So if a class has, let's say, 15 things and the sample has 30 things, then that class is a 50% of the sample. So you basically you're dividing the frequency of the class with the frequency, or should we say size of the sample. So the frequency of this class, number 1, is 4. The frequency of the whole sample, or the size of the sample, is 30. So 4 divided by 30 is the relative frequency of the first class. That's how much you have, what part of the sample is in the first class. 4 out of 30. When you divide it, you get 13%, so approximately, because I'm going to use approximation. So it's 13.3%. In the second class, you have double, so it turns out to be 26.6%. And again, how do you get that? Well, you're going to divide the frequency in the class, which is 8, with 30, which is the total things you have. So 8 out of 30 is in the second class. And that turns out to be about 27% actually, right? And then you do the same thing for the rest of them. 6 divided with that's third class. 6 divided with 30 is going to be a 20% exactly, right? A fifth. 6 is a fifth of 30, so you get 20%. I'm using 3 decimals just to write down. I could just simply write 0.2 without zeros. And then the next class is 8 again. This is already calculated here, so this class and this class have 8 things in it. They are the same the same frequency. They have the same frequency, it's 0.266. And then this guy is a half of the first class. First class is 4 things in it. This one has only 2. So it's 2 out of 30. It's 1 out of 15. That's 7%, or more precisely, 6.6%. And the last class is the same frequency, relative frequency. It has the same frequency and so therefore the same relative frequency. Okay? Sometimes people like to have a midpoint of a class. So I'm going to introduce that, although I don't have that in this example in the lecture. I didn't write midpoint. But if you want to write midpoint, it's easy to find. Midpoint of a class. What's a midpoint of the class? Well, the middle value in the class. How do you find the middle value? Well, 2.5, 6.5, the middle value is 4.5. Now, if that bothers you, how did I immediately find that? You can just add this and divide by 2. The average of these two numbers, the middle. The middle value is the average of 2 edges. So you add this one and this one, you get 9 divided by 2, that's 4.5. You can use your calculator to do that if you don't see it yourself. But I can see it's 4.5. For the rest of them, you don't really have to do much of a calculation, because midpoints moves further together with the class, so it's 4 further, because the class has a width of 4. So if you found the first one to be 6.5, then the next one is 10.5, and the next one is 4 more, 14.5. You can check it, if assuming you're not going to log your calculation to be bad. I made a mistake, of course, because I said 4.5, not 6.5. For some reason I wrote 6.5. Let me try again. So the first midpoint is 4.5, right? 4.5, 2.5, 6.5, 4.5. The next one is 8.5. Okay, the next one is 12.5, 4 more. And again, if you don't believe it, check but it is. So 10.5, 14.5, 12.5 is right in the middle. It should be. So again, if you want to calculate, add this and this, divide by 2. The next one is going to be obviously 16.5. That's 4 more than this guy, so it works. No mistake so far. The next one is 20.5. So add 4 to this guy, or add this and divide by 2, average. And the last one is, the middle is 24.5. So this is sometimes done, sometimes calculated. I don't really need anything else for the histogram other than this and this. In the histogram, everything else I can calculate. Look, why is the story? Well, the smallest boundary is the first class. The next smallest boundary is the second class. So I don't really need this. I mean, I already know what is first, what is second, and so on. Do I need limits? Not really. 2.5 to 6.5. So I already know it's going to be inside. It's going to be 3, 4, and 5, and 6, right? So I know that too. Now, okay, I need this because I can't find it from anything else. I don't really need this because this guy is the same as this. This guy is sum of this 2. This guy is the sum of this 3. This guy is the sum of this 4, and on you go. So, and then of course this one is the sum of them all. That's 30. Do I need this? Well, depends. If you're making a relative frequency histogram, which is going to be a little bit different histogram, but with the same shape, then you need that. I'm not going to be doing this, so I don't really need that, but you can easily find it out. So since you know the sum of this is 30, you already have 30 in your mind. So 4 divided by 30 is this number, 8 divided by 30 is this number, 6 divided by 30 is this number, 8 divided by 30 is this number, 2 divided by 30 is this number, 2 divided by 30 is this number. Okay, so that's it. And then the midpoint. Do I need a midpoint? Really, I don't really need it because I can find what a midpoint is. Again, this plus this divided by 2, this plus this divided by 2, this plus this divided average. So I actually have full information out of this and out of this. That's all I need. But I wrote everything in this table. You might even want to write the tally. If you're tallying by hand, you might want to write tally before you can, put the frequency. If you're not counting right, you might do the tally, right? 1, 2, 3, 4, cross 5, right, and so on. Okay, so now what's the histogram? Well, this is where the frequency is going to be. The height of a bar is going to be exactly how many things are in the class. So you might want to write some sort of a vertical axis in which you're going to have your measure. You're going to have your unit. So let's say this is going to be 1, then I have 2, then I have 3, then I have 4, then I have 5, then I have 6, then I have 7, then I have 8. You want to write the numbers down there if you don't see. Now this of course ought to be proportionate, right? It doesn't have to be the same unit as here, because this is 4 and this 4 is slightly bigger. So it's not necessarily to be the same unit vertically and horizontally, but you need to have a unit uniformly horizontally and need to have uniformly vertically, right? So this unit, this one must be the same as this one, and on you go. If I didn't do that all that great, take a look at the lecture. Lecture is a computerized graph, so it looks much better. Okay? So now I need to find those heights. Frequency 4, first bar. Frequency 8, second bar. Frequency 6. So now I'm looking at this 6 here. Third bar. Another 8, the fourth bar. And the last 2 bars are too high each. 2, 2. Sometimes, if you don't see really this alignment well, you might want to write it on top. So this is 4, this is 8, this is 6, this is 8, this is 2, and this is 2. So you wrote down the frequencies, not down but up, right? You wrote them on the top of the bar, just in case if you cannot align this. So you have bad eyesight, maybe you can say, I don't know, is this 6 or something else? Well, I wrote on the top, so it's 6. Okay? This is a histogram. Okay? So, brief check. Do we have all the rules satisfied? The range of histogram has to include the range of the sample. The sample is between 3 and 26. This covers from 3 to 26, no doubt. Do I have at least 5 classes? How many bars you have? 1, 2, 3, 4, 5, 6? Yeah, I intended to make 6 bars. Just a brief check. Many times I see from students like you in the test, I said make a histogram with 6 classes or 7 classes, and the person makes a histogram with 10 classes or 5 classes. So which means that you didn't even count how many classes you have. Okay, every class must have the same width. Is it so? 4, 4, 4, 4, 4, 4. So don't make one 5 and one 6 and another one 4, because then you violate. You don't have a histogram. If you miss any one of those, you don't have a histogram. Okay? No gaps between the classes. No gaps. Right? Every bar is attached to another bar. Okay? This is the thing you don't see, that I'm counting 6.5 in the second class, not in this one. It won't make a difference here because I don't have any purchase of 6.5, but just in case, right? So this arrow you don't see. Then class don't overlap. No, they don't. There are no overlapping things here. This is called histogram. Now, how important is histogram? Well, the histogram tells you distribution in the sample, distribution of the data in the sample. So you can see here, the most things are somewhere in this class, so which means that there is something popular, I think, in that gift shop that people are buying. There might be somewhere the price between $6.5 and $10.5. And then there is the more purchases here, and something else popular that people are buying that is between $14.5 and $18.5. And then there is very little people spend money on anything bigger than $20, right? Anything bigger than $19 actually. You don't see very little there. There's some, some cheap stuff people are buying too. That's how it looks like. This is called bimodal histogram. Why is bimodal? Because it has the two highest classes. They don't have to be equal. They just have to be like a two mountain with the two tops. Then it's called bimodal. If you have three tops, not necessarily equal, but like, you know, one like that, and another one like that, and another one like that, they will call it trimodal. Or if you have only one, you call it unimodal. Single mode. This is bimodal. It has a two, this mountain of a vertical bar graph, it has two heads or two tops. Okay? It's also called skew to the left. Excuse me, skew to the right. Sometimes it's skewed to the right, sometimes it's skewed to the left, and sometimes it's symmetric. What does that mean? Skewed to the right, it means it has a pronounced tail on the right side. Okay? You can think about it as dinosaur. And I have a tail here, obviously. This is going to be head, right? So if you have a tail that is pronounced to the right, you're going to call it skew to the right. If the tail is pronounced to the left, you have a skew to the left. That way. So skew means, where is the tail? Skew to the right, the tail of this dinosaur is on the right side. So it has two features to remember. Bimodal, unimodal, trimodal means how many tops you have. Uni means one, bi means two, tri means three, and very unlikely going to run into, it's going to be four tops, but you could have if you have lots of data. And skew to the right or skew to the left, it's going to be one of the two. And if you can't find a tail, if you both sides are looking about the same, then we call it symmetric. Or we don't say anything at all. If it doesn't look symmetric, but you can't find a tail, we don't have a histogram that is skewed either way. Okay? So let's do another example that you're going to see in the paper. In the lecture paper. Then you have a little problem because you're going to have, in this example, you're going to have the things that are on the boundary. On the boundaries. Because I didn't have this problem with the with this example in the purchases from the gift shop. But now I have another example. This example says professional football players' age. Random sample from 6 teams. So probably cluster sample, six different things. I don't know how many are in NFL. 8, no, 6, I don't know. I don't really know. 48 or 36, something like that. So this is a random sample from probably, so this is a cluster sample. So we have the different teams. So we selected 6 random teams, and we got the ages from the players from these teams. That's a pretty large sample. I can see I have 40 things. The first thing I did once I collected the ages from these 6 teams, I realized I have 40 things here. So that's a large sample because it has to be 30, right? And I ordered that. So I was using again the calculator, obviously. You can also use the Microsoft Excel spreadsheet. You can order it very easily in there too. But you have to use something like that. If not, you're going to have to basically, sort it yourself manually. Like I was saying, find the smallest one, cross it over, go for the next one, and so on. But it's going to take some time to do that. And once I ordered it, I realized I have 2 guys with 21 years of age and then 22 and so on. And I have the oldest guy in the whole sample is 37 years of age. So I have my range between 22 and 37. So that's the range of the sample. Now notice this is 16, right? 21 to 37, subtract. 37 minus 21 is 16. So the range of the sample is 16. If I use 6 classes, and I might do 7 classes here, I might do 8 classes, I don't know. Depends on what you like. I personally was selecting the 6 classes because I noticed that lots of numbers are the same here. So for example, 22, 22, 22, 22, 4 times, and then 23, 1, 2, 3, 4 times, and 24, 3 times, and so on. So I know that I'm not going to have big distinction between the ages here. So I don't really want to do, the class in which I'm going to have only one age and then another class, so on. So I think, I have the range of age here between the players from 21 to 37, that's just 16. So I decided I'm going to use 6 classes, not too many. Okay, now what would be the width of a single class? Well, I have the 16, which is the range of the data. I know I have to cover all of that, so I need to divide this 16 with 6. 16 divided with 6 is precisely 2.5. You try yourself. It's very easy to do that. 16, the range of the sample, 6 classes. If you divide that, it's going to be 2.5. So now I know that my classes, 6 of them, have to cover 16 from 21 to 37. So I could choose, so the single class would to be at least 2.5. I could choose 2.5, I could choose 2.6, I could choose 2.7, and so on. I want to work with the whole numbers, integers, so-called integers, whole numbers. So I'm going to use 3. I can't use 2 because 2 would not be enough. The range of the data is from 21 to 37, that is 16. So if I use 6 classes, each one of them with the range 2, I get the range of 12. 6 times 2, and that's not enough to cover the range of 16. So I need to use 3 if I want to use a whole number. So I decided that a single class, the width of a single class is going to be 3. Okay? And now I have my boundaries. I could start with, I know that I have the range of a sample, which is 16, and the range of classes is going to be 6 times 3, 18. 6 classes, 3 for each class. 6 times 3, the range of classes, the whole width of the histogram is going to be 18. 6 times 3. So 18 will cover the range of 16. If you have something that is 18 inch long and you want to cover the object that is 16 inch long, you can cover that object so that you have an extra on each side of 1 inch, right? You have 18 to cover 16. So you have 18 an extra inch on each side, that adds up to 18. So that's what I'm going to do. So now I already know what my boundary is going to be. I'm going to start with 20, which is 1 inch, not 1 inch, but 1 year younger than 21, and then I'll go all the way up to 38, which is 1 year above 37. So I'm having now the range of my classes from 20 to 38. That covers the range of the data, which is from 21 to 37. And my classes are, of course, 3 years wide. So I have from 20 to 23, that's the first class. From 23 to 26, that's the second class. From 20 to 29, that's the third class. From 29 to 32, the fourth class. From 32 to 35, fifth class, and the last class is between 25 and 37. And you can see my arrows are pointing out again to the right, which means that the right edge will be included in the next class. So means left in, right out. I know I cannot have this one piece of data in 2 classes. They don't overlap, so classes cannot overlap. So I need to decide, if I have 23 and I do lots of 23s here, I have to put that in either the class up to 23 or the class that starts with 23. So my decision is to put it in the class that starts with 23, the next one. Okay? The class limits, well, in the first class I have 20, 21, 22. 23 goes to the next class. The next class is 23, 20, 24, 25. The next class is 26, 27, 28. The next class is 28, 29, 30, 31. The next class is 32, 33, 34. The next class is 35, 36, 37. Okay, those are the things that are in the class. Right, so those are the limits. Okay, here's my table. Excuse me, table. Here's my histogram. So you can see down there the range of oh, I'm asking you here, complete the table yourself. You can do that. So what is going in the table? First class, second class, third class, fourth class, fifth class, sixth class. The second, what are the limits? I already wrote them down there. 1, 2, 3, 4, 5, 6. The next thing, what are the boundaries? 20 to 23, 23 to 26. The second class. The third class, 26 to 29. The fourth class, 29 to 32. The next class, 32 till 35. The next class, 35 to 38. So you already have, those are the three columns of the table, the three beginning columns of the table. Then you would have to write cumulative frequency. First you have to, first you have to find the frequency, then cumulative frequency, then relative frequency, and maybe the midpoint if you care about midpoint, okay? But I can tell you what are the frequency quickly. So in the first class I have, the limits are 20 to 22. So look at my sorted data here. 20 to 22, I don't have any 20, but I have 21, 21, 22, 22, 22, 22, 6. 6. That's the frequency of the first class. The second class has limits of 23 to 25. So you have 23, 24, and 25. So you have 23, 1, 2, 3, 4, 24, 5, 6, 7, 25, 8, 9, 10, 11, 12, 13, 14. 14 in the second class. That's a big class. 14 out of 14 guys out of 40 have the ages either 23, 24, 25. Okay. The next class, 26 to 28. I have 26 here. 1, 2, 3, 4. I have 27, 5, 6. I have 28, 7, 8, 9. 9 is in the third class. Okay, now the next class is 29 to 31. Right? Those are the limits. So I'm thinking what is here 29, 30, 31. So let's see. 129, 2, 3, 4, 5, 30, 6, 31, 7, 8. 8 is the fourth class. Okay, the fifth class, 32, 34. Well, I have 30, 32, I have 33, I don't have any 34, so that means these two guys only. 2. And now the last class is 35 to 37. It looks like some old quarterback. Only one guy, 37. I don't have 35, I don't have 36, only 37. But here is the histogram. So you can see down there, this is how the histogram must look. It has to look nice, right? Sometimes people do the potato things, or some circled rectangles and things that are not really having right angles and all sorts of stuff. It has to look nice. Those bars have to be rectangles, and they have to be proportional with respect how much is in those bars. So I already know that the boundaries of the first class is between 20 to 23, the second class 23 to 26, the third class 26 to 29, the fourth class 29 to 32, the next class 32 to 35, the next class 35 to 38. That's all perfect. I already told you that in the first class I have 6 things. There was a frequency. I counted. And the next class I have 14. We kind of are surprised we have so many in that age group between 23 and 25, 23, 24, and 25, right? The 26 belongs to the next class. Now in the next class I counted 9, and then the next class 8, and the last class was 2 and 1. And that's exactly what you see here as a height. So you can relate this because it's very precise. You can clearly see that, unless you have a bad eyesight, right? That this leads to 9 here. If you don't see that very well, you write here 6, 14, kind of beside the point. It's obvious 6 and 14. But this one here, okay, 9. This one here is 8, obviously. I have those little horizontal lines. You can see the alignment. This one is 2, obviously, and this one is 1. Okay? Now, what do you have here? You have a unimodal histogram. There's only one mountain top. Okay, so it's unimodal. It's skew to the right again. Now, the previous histogram I made on the whiteboard was skewed to the right, but it was bimodal. This one is unimodal because only one mountain top, this thing here, and but the tail is on the right. So again, just like in the previous example, the tail is on the right, so it's skewed to the right. Okay. Now, you could say I don't like this because you know what? You have too many things on the boundaries. You have lots of guys that have an age of 23. I don't like that. And then you have lots of guys that have an age 26. And again, you're on the boundary. So it's kind of like a decision where you're going to put it, in the next class or the previous class. So you made a decision to put it in the next class. Maybe there's some influence how this looks like. Okay, well, you can adjust this. So you can use boundaries to be fractions. So instead of starting at, so I said, let me see this one more time, how I decided that. I said the range of the classes between 21 and 37, and each of the class is going to have, each class is going to have the width of 3. So instead of starting at, like I started at 20 and I ended up at 38, you might want to start at 20.5. And that way you're never going to have a problem with the boundaries, because every next boundary is going to be fractions. So you have 20.5, and then I add 3, you get 23.5, and add 3, 26.5, add 3, 29.5, add 3, 32.5, add 3, 35.5, and add 3, 38.5. So that's perfectly okay if you want to do that. So I did it here. I decided to use this as boundaries. This is slightly biased. It's not really all that big deal, but it's slightly biased because the lowest age I have in this group of players is 21. Okay, so I'm starting with 20.5, which is about 0.5 less than 21. And the oldest guy is 37. While I'm ending my boundaries at 38.5. That's 1.5 ahead. I mean past 37. So basically I'm having a slight bias. I kind of cover more the right side than I covered the left side. So the 37 is well covered, and he's got a year and a half over. And this toes here, you can call it toes, I don't know, which is 21, is just have a, half an inch here, or shouldn't say inch, a half a year here. So it's slightly biased. But I avoided to having anything on the boundaries because there will be nothing on the boundaries. Ages are not 23.5, it's just 23 or 24. So I'm going to have boundary problem. So which is, another problem that you could have, because now you have to think about, is that thing that we approach legit enough? So I was saying that, left in, right edge, the next class, the left in, right out. You might want to choose differently. You might want to choose left out, right in. So, but if you do this here, you won't have this boundary problem. What is the change of the histogram? You can count yourself. In the first class, you're going to have 21, 22, 23. So the boundary is between 20.5 and 23.5. The next is 23.5 to 26.5. The next 26.5 to 29.5. And 29.5 to 32.5. 32.5 to 35.5, 35.5 to 38.5. Make your table yourself. Okay, you will find out you have a 10 in the first class, 14 in the second class. Didn't change really. Second class, in the old graph still 14. The first class changed because now I have a 10. The third class is also 10. The fourth class is 4, and the last two classes 2 and 2. Not much in the shape change. Okay, I'm still having a unimodal histogram, 1 mountain top, and I have skew to the right. Slight change in the shape, but not in characteristics. I'm still the unimodal and skew to the right. So yeah, it could be slight difference. You could also start with 19.5 and go all the way to 37.5. That is also 18. You will also have a 3 and 3 and 3 and 3 and 3 and 3, your classes. Starting with 19.5, first class ending at 22.5, the second class ending at 25.5, then 28.5, then 31.5, then 34.5, and the last one is going to be 37.5. And you will again cover all the data. You probably get a slight difference, and I bet again you will have a unimodal skewed to the right histogram. So it could change. So this choice, how you're going to cover that or over cover that, is slightly in the eye of the beholder. Okay. Here's another example. I'm just going to go briefly through it, and you're going to read it. Carry-on luggage in pounds with a 40-passenger sample in the Hawaiian airport. I didn't tell you which one. I guess the international airport in Honolulu. Okay, the first guy is carrying on, and this is something you drag into the cabin. The first guy has 30 pounds. That's fairly heavy. The second guy has 27 pounds. Then 12 pounds, 42 pounds, all sorts of different things. There's one guy who has no luggage, Zippo. Maybe a wallet, probably, but nothing carry-on. There's one person here with 51. Now, the first thing you need to do is to sort this. You will have to sort this stuff. So if you sort this stuff, you will see that the smallest thing is 0. That is kind of obvious because nobody has negative luggage. And the biggest thing is 51. You might want to look through it. There's nothing that is in 50s. There are some things in the 40s, certainly nothing in 60s. So there's only one thing in 50, and that's this guy here. So that's the biggest number. So we're having something from 0 to 51. The range of the whole sample is from 0 till 51. Let's say 6 classes again. I'm not making anything very original here. Again, 40 things, just like those players in NFL, 40 things. I can get the 6 classes again. Okay, it has to cover the range between 0 and 51. So if I divide 51 with 6, I want 6 classes, I will have to get 8.5. Now, 8.5 is the width of a class that minimum to cover all of the data. And again, I don't want to work with the fractions, I want to use 9. So, if you choose 9, and you need to cover something between 0 and 51, with 6 classes. 6 classes, 9 width for a single class is 54. So 54 will cover 51, between 0 and 51. So which means if I want to be completely unbiased here, I'm going to use between negative 1.5 up to 52.5. Why is that negative in the game here? Because I'm having the beginning of my whole sample is 0. And the end of my sample, the end of the range is 51. So if I have to cover the 51 object that is 51 long, I need to cover that with the 54. That means I have a 3 inches extra. Not inches, but in this case pounds, right? 3 pounds extra. So I'm going to use the half of that, 1.5, below the smallest one, and half, 1.5, above the biggest thing. So the smallest one is 0, so 1.5 below 0 is negative 1.5. And 1.5 above 51 is 52.5. So here is my story. I have the boundaries, negative 1.5, 9 more. Add 9 to negative 1.5. Use a calculator if you can do it yourself. 7.5. Then 9 more, 16.5. 9 more, 25.5. So the boundary goes from 16.5 to 25.5. The boundary again, 25.5 to 34.5. The next one, 34.5 to 43.5. The next one, 43.5 to 52.5. So what are the limits? -1 to -7 in here, in the first class. You can say, well, you're never going to have -1 pounds of luggage. No, yeah, I'm just approaching this theoretically. I mean, I could say 0 to 7, but then you might get confused. Why do I have this -1.5? So let's say -1 to 7. You're not going to count anything with -1 for sure. This one is 8 to 16, right? Starting with 7.5, you can have 8 only, and all the way to 16, and you don't go any further. The next one, 17 to 25, 26 to 34, 34 to 43, 44 to 52. Tally, if you count this. So I'm lazy here. I'm lazy here to do the input in my calculator. I still have it open, but I'm just lazy. So how do you tally that? Well, let's see the first class, or let's go for the second class because it's kind of easier to see. 8 to 16, 8 to 16, all right? Nope, nope. 1, tally that, 1. Nope, 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 nope. All right, nope, 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 no, 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 no. Just 1 so far. No, 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 no. 12, 2. So in my tally I have a 2. 22, 18, 21, 26, 43, 18. None of them is 8 to 16. So I have only 2. I counted only 2 things. So this is the tally, right? This is if you don't order the data. You're going to have to tally it because you're going to have to go through it and find everybody that is between 8 and 16. So I found 2. The frequency of this class is 2. So now I have this extra column of tallying. Now if you sort the data, you're not going to have to do that. And it's not going to be much easier because you're just going to, as they go from left to right when they're sorted. So I have 2, 2, 9, 16, 8, and 3. Check it out. Do the tally yourself. This tally is undoubtedly right. So I have this class, people carrying something between 26 and 34 pounds into the cabin. Most of them, I guess. I don't know. It's a tourist airport, so they carry lots of stuff. I have cumulative frequency. This is 2. This 4 is this first 2. This 13 is this first 3 here. 29 is all of these 4 guys, and you can just simply add 13 plus 16 because 13 is these 3 guys. And the next one, 37, is all of these 5, and the next one is 40, all of the 6. And relative frequency, what do you have? 2 divided by 40, that's 5%. 2 divided by 40 again, that's 5%. 9 divided by 40, okay, that's 22.5%, exactly, it's not approximation. 16 divided by 40, that's 40%. 40% of the sample is in the 4th class. So give you some idea. 40% of the people in that airport are carrying something between 26 and 34 pounds, right? Then you have 8 divided with 40, that's the 20%. The 8 is a fifth of 40, so that's in the next to the last class. And in the last class, you have a 3 out of 40. 3 divided by 40 is 7.5%. Okay? Again, I said, if you have any problem with this negative number I'm starting with, you can start with 0. You're going to have a 0, 9 more, 9, 9 more, 18, 27, 9 more, 36, 9 more, 45, 9 more, 54. So your classes are going to go between 0 and 54. It's sort of biased because the first piece of data is at 0 and you were just starting there. And the last piece of data is 51 and your last class is going to be 54. But you can do it. So if this unbiased approach in which you get the negative numbers here bothers you, you can start with 0. No problem at all. You're just going to have slightly different looking histogram. But this is what I got. So again, I have negative 1.5, 7.5, 7.5, 16.5, 16.5, 25.5, and then to 34.5, 43.5, 52.5. This is precisely what I'm writing here. So this boundary is right here. Okay, and then I now have frequency 2, 2, 9, 16, 8, 3. 2 the height, 2 the height, 9 the height, 16 the height, 8 the height, 3 the height. If you don't see this very well, this is a line up nicely, but if you don't see very well, you write here 2, 2, 9, 16, 8, 3. Okay, so that's my histogram for carry-on luggage. I did not make another histogram that will be if I use the boundaries between 0 and 9, and 9 to 18, 18 to 20, what did I say, 27, 27 to 36, 36 to 45, 45 to 54. I'm leaving to you. I'm leaving that to you. Make that histogram. You're not going to have anything negative, so it's going to look more natural, but it's going to be slightly biased because you're going to have a lot more of your histogram over 50, right? The biggest thing you have in the whole sample is 51. There's nothing else in the 50, and all of a sudden your histogram is having 51 and 52 and 53, and it goes up to 54. It's kind of bias, okay? But again, we have here unimodal histogram, but this one is skewed to the left. You see the tail is on the left. If you look at this, some kind of lizard or turtle, I don't know, there's a tail right here. So it's skewed to the left. It's unimodal. I have only one mountain top. It's unimodal, but it's tail to the left. Okay, I have some more stuff here. It says the frequency polygon and the ogive. Okay, I'm going to explain these curves. So these are curves. They're not histograms. These are curves. I'm going to explain what these curves are all about in class when we meet the next time. When we meet the next time, when we have live in class, I'm going to tell you what is this story about the frequency polygon here, and what's the story about an ogive. That's what it's called, ogive. So the two curves associated with the histogram. Okay? You do have a pretty big homework on histogram, in which you're going to be doing your own histograms in the homework. The author of the homework will ask you, the Connect Math guy is going to ask you, show me the boundaries, show me the limits, show me the relative frequency, why this, why not that, and so on. So you'll find out, and eventually you will have to draw something by using some software over that. So do that. But if there's any question about the frequency polygon, now this is a frequency polygon, we call it frequency polygon, this kind of curve. It's associated with the histogram. It has something to do with histogram. It's sort of overlay of this histogram, right? Kind of the same shape. And then there is another curve here that doesn't have any shape of a histogram here at all, but it's also meaningful. It has a name, ogive. It's called ogive. I'm going to explain that in the class. So the next time we meet live, I'm going to explain that. Okay? So I'm hoping you're going to watch this video, and of course if you don't understand something, you can definitely ask me in the next class, and you can certainly what you can do is basically you can bring the homework question if you try homeworks in the class as well. And we will definitely spend some time explaining this curve and this curve here. So the next class we have is again going to be about a histogram, either your questions or I'm going to do one example of a histogram for you if you want me to do that, and we're going to explain these two curves. So if you try homeworks and you have some questions from the homeworks, it'd be nice to work on that. Okay? So I'm done. I'm going to stop recording here, and I'll see you next